Go.
Let's kick it off.
Hello, everyone. Oh, wow. Hello, everyone. That's better. Yeah. Okay. So welcome to the first session of Oauth. We have a session that is shared with the ACME. So the first an hour and a half will be Oauth. Yeah. And the last hour of this will be an ACME. So we have 90 minutes here. This is obviously the Note well. Everything that you say or contribute here is still under the Note well, so make sure you're familiar with this. We have a Jabber scribe, Ludwig, thank you for that. Minutes takers, Mike and Justin, thank you. And blue sheets are circulating already. I like it, that you don't have to be too close to it. This is good. Yeah. We have one document that was recently published, a RFC 8414. That's the authorization server metadata. And congratulations to the authors. I think Mike, Nat, and John. Is that correct? Okay. Thank you, guys. Quick status update here. So
what's the schedule here?
Can you guys close the door? Sorry. Thank you. And so I think the Oauth was just released or something. It was the Oauth, right? It was just.
So before this session, or in preparation of this session, we met with some of the draft authors to do the Shepherd write-up for the device flow and also for the best current practice document.
That would be the BCP and the MTLS, right?
Oh, that's true.
Yeah,
From
yeah,
MTLS and BCP,
the device flow.
The device flow, Eka just sent me an email. The device flow moved into ballot, which is so it got advanced, which is good. And he needs to review Nat's document on the JWS request signing. And actually, so there's an action item for us to go through the comments to make sure that we sort of summarize on how we address the different ISG comments, so that that would obviously help Eka to advance the document faster, because he needs to also produce a write-up for the document going forward. It's not just the working group, the Shepherd doing the write-up, but also the responsible AD to do the write-up. So I will talk to Nat and the other authors to work on that, to explain, I think, which is something, not an unreasonable request, to explain how the comments have been taken care of.
And the rest of the documents will probably discuss most of those. So I think incremental authorization will be discussed today. Again, JOT, BCP, and MTLS, we started that write-up. Reciprocal will be discussed today. Security topics, token will be discussed on Thursday, and token binding and token exchange will be discussed later today. Okay, so here is our agenda for the day. So we will start with the incremental authorization by William. I think he's representing remotely. And William, can you join the line here?
everyone?
Hey, we can hear you. Go ahead.
Great. Do you have my slides up?
Yes. Yes, the slides are up.
Okay, great. Yes, so thank you. So I'm here today to talk about the Oauth 2.0 incremental auth, which was recently adopted by the working group. So thank you for that. Next slide. Let me just recap why we're doing this. So the problem statement is something like this. Asking for the kitchen sink of scopes up front can often be a bad thing. Users will frequently want the context of an authorization request. So for example, if an app needs both the calendar and the contact scope, then actually asking for those different scopes in the context that they're actually used in the app is something that makes sense. Can I go to the next slide? So this is basically what we want to avoid. And I think this is particularly relevant in this sort of new era that we're entering where people are very, very aware of the data that they're sharing and kind of considerations like that around OAuth. Next slide, please. So the definition of incremental auth in the spec is the ability to request additional scopes in subsequent requests, adding to a single authorization grant representing all scopes so far. So you could, of course, implement this just by making completely separate and discrete OAuth requests and then tracking them all individually. But the fear is that that is something that's challenging to do. If an app needed, say, 5 different scopes and wanted to request each of those separately, it would then have to track 5 separate authorization or 5 separate refresh tokens. So the advantage of incremental auth is that they get grouped together into a single grant that represents everything the user has granted so far, particularly relevant for public clients there. Next slide, please. So when it comes to confidential clients, in fact, OAuth, the existing spec doesn't actually stop you returning more authorization than what was requested. So a lot of people kind of implemented this as a way of delivering incremental auth for confidential clients. So the value of the spec when it comes to those is the inclusion of some best practices, security considerations, and one additional parameter, which is include granted scopes, which is a way that a confidential client can kind of indicate that they want all of the granted scopes so far to be included in that response and not just the one that they're currently asking for. Next slide, please. The real innovation of this standard is to document how public clients can do incremental auth, because that was previously not possible at all. And we're doing that by a new token endpoint called existing grant. So let's go to the next slide and I'll walk through the. So when basically the app does 2 requests, the first one is completely normal OAuth for native apps. And then the second one, the first 2 steps are exactly the same as normal OAuth, so they'll just request whatever scope they wanted. But if you look at the second to last line at the bottom there, when they're exchanging the authorization code for that second grant, they include in a field called existing grant the refresh token from the first request. And that will result in the access token and refresh tokens being returned on the bottom line there, containing the union of all that scope. Next slide, please. So this is just visualizing how that works. So you have grant A and grant B, and then what should be returned is the combined grant, the union of both. Next slide, please. Okay, so updates since the last IETF. It was adopted as the working group, which I mentioned, which is great. And I've been working here at Google, looking with some other people kind of testing this out and sort of seeing what else needs to be added to the draft. So it looks like one thing we may want to document is exactly how the scope response parameter works with this draft. It's sort of already documented, but it might be worth some best practices around that. We, of course, want to provide an RFC 8414 metadata field, now that that's an RFC, so woohoo. And the big thing is interop and also, I guess, reviews. So thank you, Torsten. I saw your review this morning. I really appreciate that. But yeah, I really wanted to send out a call to action here. If anyone is interested in this spec, and if you have a client or a server that can potentially use this, very interested to get in touch with you and to work on some interop there. So that's probably going to be one of my main focuses going forward between now and the next IETF. Next slide, please. And so with that point in mind, I'm happy to announce that the Oauth iOS library does have support for this standard now, particularly the public client one. I realize we don't normally show code, but I just wanted to show this because it's actually just to emphasize how simple it is. So this is like literally the sum total amount of code that a client would need to provide in order to increment an existing grant they had with the calendar scope. That is literally all they have to do. And so this is kind of like why I really wanted to push this. And that is, if we make this really easy for people to do, then I'm hoping more people will do it. And I think it's the right thing for users. And so if more people do the right thing for users, then we all win. Next slide, please. And I've published a demo using this new API. So the API, by the way, it hasn't actually been merged yet. It's in a pull request. But if you are an iOS developer and you click this link, it'll have everything, a demo showing how this works using those new APIs. So you can try that out. And as I said before, I'm really interested to get some interop happening. So I'd love if anyone's implementing this server side, it'd be great to point this demo at your server too and see if it works and see what problems we have, if any. All right, last slide. So that was my update. Very, very interested to hear what people think of it too, if anyone else has had a chance to review.
Descartes, Amazon, nice.
Thanks. All right.
Any more elaborate comments?
I guess we can go over Torsten's feedback from earlier today, if that's of interest.
Yeah, go ahead.
Yeah.
So there are a couple of points raised. Do you want me to summarize them?
Sure. Do you want me to share those? I think.
Yeah, okay. It should be under, yeah, there it is, third from the top.
Yeah. This one.
Great. So there was two pieces of feedback here. One was the way we documented how the unioning is done on the authorization grant. Torsten noticed that I had a should in the spec there rather than a must. And I can actually pull up the spec as well. So the reason I originally had a should there is I'm trying to kind of balance two competing things here. Let me just read the section. It says if the verification succeeds, the new refresh token issued in the access token response of the token endpoint should include authorization for the scopes in the previous grant. So it's basically saying when the client provides the existing grant parameter, any new tokens issued should contain the scopes from that parameter. The only reason I really made that a should, not a must, is I kind of always feel like it's up to the authorization server what they want to do. But it is probably a little bit confusing to say that's a should there, because if you're sort of not doing that in a normal case, then you're not really implementing this spec at all. So my plan there is to actually change it to a must, but kind of qualify that with some words to say, ultimately, it is in the discretion of the server what they want to grant. But if you're implementing this spec, in the normal case, you must include that. So I hope that makes sense. I'll just pause in case there's a comment on that feedback.
Annabelle Backman, Amazon. What about situations where the authorization server wants to support selective consent and potentially include in that the ability to, revoke previously granted scopes? How would that work if this is a must?
Yeah, good question, and I think that's probably another trend that we're going to see actually. So yeah, very topical. And for the most part, I think that can already be implemented in the bounds of OAuth. So I definitely wouldn't want to have any text there that would tie anyone's hand around selective consent. So I guess what you're saying is potentially the existing grants could be shown on that incremental auth screen. It's not something that at least Google's implementation does today, but they could be. And the user could actually revoke something as they reviewing and maybe granting or maybe not granting the next one. So I totally agree with your comment. It's going to be hard to come up with some good words around that. But I think we can probably word it such that it accommodates that.
Yeah, I think your original kind of instinct is making that a should, or at least not a must, is right. I don't think if we make this a must, then we are tying implementers' hands with regards to things like that.
Right. I guess the wrinkle is if you interpret a should, if you actually kind of never do it, then you haven't implemented the spec. I suppose maybe that might be worth noting. But yes, it's more like in the normal case, you would consider that existing grant and likely bundle that in. But I guess either way, if we keep it as a should, maybe I can just clarify that. If you actually never do that, then you're probably not implementing the spec at all. Does that?
Dick is telling me he has a suggestion, so I'll let him talk.
Okay, great.
Maybe framing it more, Arne, that the response must include all the authorization that the user is granted. And so by putting the user into the equation, then you're tying it to what the user is granted as opposed to whatever the server decided as being previous grants, right? So that way, if any came in and out, it makes it clear.
I like that, actually. I think that should solve it.
Comment from the Jabber from Torsten Lodderstedt. The alternative is to return the scope with the token response so the client can determine what happened. But apparently that's what he just said. Sorry.
Yeah, actually, that is a very good point from Torsten. This is something the spec does not document today, that it should. So I think the OAuth spec actually already documents this behavior. So if you are returning an authorization with sort of different scope than what was requested, you're actually meant to populate that field. This behavior is not mentioned. It's highly relevant for incremental auth. So I'll definitely take that as a note to add something as well regarding that parameter. And like Torsten says, that is actually a good way for the client to figure out what the heck happened. All right, so the second point here is the spec goes into a little bit of detail, kind of some best practices around how to handle denials in the case of incremental authorization. One of the things is kind of not throwing the baby out with the bathwater. If the user were to choose no for a particular authorization scope, then you shouldn't like completely abandon all the grants that you have so far. The app should actually continue operating. I think this is very important from a user standpoint. You don't want to kind of badger the user or like really insist that they're granting scopes they don't want to. That's the whole reason why we created this spec. But Torsten raises the point about how should the server handle it. So I'll definitely add a section in there. I totally agree with the assumption stated here, which is that also the authorization server would not normally discard any previously granted scopes if the user didn't explicitly indicate that.
Dick Hart again. This brings up sort of another question. I don't know whether the working group has looked into this anytime in the past, but standardizing token discovery endpoint where a client could call a known endpoint and get back all the scopes that were in the token. So then they could learn what do they have now, and then they would know what do they need to ask for. A number of the providers have a proprietary API for that, but standardizing that could simplify work for developers.
Well, I've seen people using token introspection from the client to actually see what's rather than the resource server used for that purpose. But you're right.
Yes, I agree. I know Google more or less implements the token introspection spec, which I think was actually not designed for that use case, but it kind of almost works for it.
Annabelle Backman, Amazon, a similar point to what I said earlier. I think we want to avoid assuming that an authorization server isn't going to revoke previously issued consent. if that's what, they may want to allow the user to do that through that UI. If you're a user seeing a bunch of stuff that whether you've granted it or not, whether this is new stuff that you're granting versus old stuff, if you hit cancel, what does that mean?
Yeah.
Maybe it means you cancel everything.
That's a good point. Well, for one, I think I'll make sure like the spec doesn't tie anybody's hand related to that. I think it's, everything is up to the authorization server. I mean, I am interested to capture usability best practices and kind of give advice to people implementing this. So that is an interesting question. It's normally we have a yes or a no, and this is actually like a yes, no, and then there might be some other actions for the users. So do you think that's worth documenting?
There's probably room for a best current practice around that, but I have no idea I don't think we as a community know what the best current practices for consent and revocation are. So that's a project in and of itself. Indeed.
So maybe just some non-normative text, just sort of presenting this as something that should be considered, I guess, by implementers. Is that?
Yeah, at the very least in like a consideration section, perhaps.
Right.
Another thought is, I guess the question is, do we actually have an access denied use case where the customer or the user is not revoking everything? Like if I'm a user and I reject the new scopes, but the authorization server still says the old scopes are valid, does it make sense for that to be an access denied, or should that be a success and just issuing you back the scopes you had previously? Because technically you're still authorized, just not for the new stuff. So one of the problems is for public clients is that at the time of the authorization, it can be a little bit hard to know what scope that particular public client actually has, because you can imagine a case where there are two installs of the same public client used by the same user that potentially have actually different scope, which sounds weird, but is certainly possible. And I've seen this with some like cloud-based CLI tools. So the way the spec is designed is actually the kind of incremental request. If you deny it, it really just means like you're just denying that particular scope with no implication on the previous one. Which might not actually be the AS's behavior.
Because they might be, sort of revoking scopes in the background. Yeah.
So I'm saying if we're going to support that kind of a use case where there could be a revocation of everything, then maybe it makes sense for us to reserve access denied for the case where everything's getting revoked. And in all other cases, you're authorized, but you need to check what you got authorized for.
Yeah, so I think the only blocker right now to implementing that is that the server is not getting an indication in the request exactly which grant this relates to, because you could have two simultaneous grants to the same client ID kind of in parallel. And so there's actually no way, if you're supporting that behavior, there's no way to kind of correlate them right now. We did have one idea about this, which is on the authorization request, the client could provide like an access token or something to sort of hint to the authorization server which grant this is, but right now it's not documented.
The authorization server has to be able to know what is like what's consented and what's not, like in order to present it to the user.
So imagine, well, actually, the way this is specified, it would only present the new consents. So it knows what's being asked in that incremental authorization request, so it knows what to present in that context. So to give an example of what I'm talking about, like imagine you have a cloud product with various different scopes, and you have like two laptops and two command lines, both interacting with some cloud tool. In that case, it's the same user and it's the same Oauth client ID, but you could potentially have like one laptop with less. So
now,
iOS
and Android app on different devices. Sure.
Right. And so right now, the authorization server, in the context of that incremental request, doesn't know kind of which of those grants it is. We could document another parameter on the request.
I agree. I agree with your statement insofar as it applies to the protocol as written today.
Right.
I don't think, though, that we want to go down a road where public clients and confidential clients are necessarily given different user experiences, which sounds like where that would lead.
Okay, so the simplest way I think to solve this is if the client includes an access token on the second authorization request. Do you see a problem with that at all if we were to do that?
Besides putting an access token in the query string?
That's the problem. I mean, how else can we indicate? I guess we could hash it. I mean, how else do we indicate to the authorization server kind of like this incremental request relates to an existing grant that has been made in the past?
I can tentatively think of some ideas, but I don't want to try and blurt them out here in 30 seconds.
Right.
So
let's take that as an action item.
Let's continue that discussion.
All right, it sounds good. I think this is an excellent topic. Thank you for raising it.
Justin Richer, and while we wait for Annabelle's ideas, the thing that I'm hearing throughout this entire discussion is kind of coming back to the fact that Oauth 2 does not have any type of sort of structural model for what a grant is. And so that might be something that we as a group may want to take like half a step back to think at. About how this works, how we might be able to chain multiple things together. Because ultimately, if you had a way to identify a grant, you could build up this kind of stuff, that there might be something going on there. There are a lot of other systems that, there's UMA and SIBA and even the device flow have all these temporary tickets to kind of tie different parts of the process together here. So we have approached this from a lot of different directions, but fundamentally, there is no object that is the authorization grant that we agreed on, that like this is what it is and these are what the parts are, which is why all of these assumptions about like how is this stored, how is this referenced, what does it apply to, is going to be completely different in every single implementation. So, I very much sympathize with the not wanting to tell authorization servers what to do, because they've been doing it a certain way for very many years, and coming in and saying that, no, our model is better than the model that you correctly interpreted from the vague specification is not going to fly. So anyway, that's something to consider. What I actually got up to talk about, though, was that the introspection specification, we intentionally wrote that to be slightly vague as to who's supposed to be using it. The primary use case is very definitely the resource server talking to the authorization server. That's the job that it was meant to solve. However, if you look at how the spec is written and kind of what it allows in different places and stuff like that, the client can use it without really going off book. The trick, of course, is to have your authorization server implemented in such a way that it can safely allow clients to introspect, which is not as simple as it seems on the surface. Having implemented that in several different systems, there are a lot of gotchas about allowing clients to ask what a token is good for. So I think that's if you want to go that route, that's the place to start, and some additional considerations for how to use it properly within that context is probably the right way to go about it.
Do you think we should actually document that use case here, or that, or are you just saying that's just a separate thing?
I think that if it's if we're going to recommend the application of introspection to help solve this, this whole notion of I'm going to go look up what my token's good for, and so that I only ask for the delta, or I go look up what the token is for to figure out if I got what I asked for, or something like that. Then we should document that here, the sort of the AS implementation and security considerations for token introspection as used by clients for this. I think that would be good here.
Yeah, I mean, one of the goals of this spec is to document how that scope return value would be used to indicate to the client like what scopes they have to avoid the necessity of that lookup. But
Right.
they might forget, or they, something might happen. So
Yeah, and fundamentally, we all seem to sometimes forget as a community how stupid OAuth clients are, and how they're not going to do most of the clever tricks that we allow them to do with all of these specifications. They're just going to blast tokens until it works.
Justin, I was just wondering whether it's really a good idea to do token introspection from the client when you're only interested in the scopes, because it's essentially you get the token, you send the token back. There's one additional round trip, lots of data being passed around. You may get actually realistically more back than just a scope. You actually get a lot of data. So like seems extremely wasteful, like in terms of what the round trip and what goes over the wire. Wouldn't it be more sensible to actually pass a parameter along that comes back with the token saying, this is the scope that I actually granted. You asked previously this in the request, and here's what you get. Or is that,
I didn't say introspecting from a client was a good idea. I just said it was allowed by the spec.
That's true.
Or not strictly disallowed, to be pedantic. So yeah, there are a lot of downsides. And one of them is that the data model that you get back from introspection is intended for resource servers. It's got a lot of extra information that clients generally shouldn't know anything about. Also, going back to the point about clients being stupid, generally they're going to use the token and see if it works. I mean, most OAuth clients that I have seen in the wild ignore the scope field.
right.
They get a token, it's a 200, the access token field is there, they're happy. They don't check expires in, they don't check scope, they don't do anything else. If I get the access token, I'm going to go call the API. Hey, the API failed. Guess I need to go bother the user again. And maybe pop up a screen that says, no, user, really do click this or I can't give you the widget you wanted. For most clients, it doesn't make sense to do that extra round trip because they're doing a round trip to see if the token is any good by using it. And they already have to have appropriate recovery for that failing anyway, for the token being revoked or not being strong enough or having expired or any number of other things that they already have to write. The tendency is to reuse those recovery code paths as opposed to trying to do something more smart and proactive. That said, there are a handful of people who, especially with kind of back-end system clients that can afford to be a little bit smarter about things, or it's worth putting in a little bit extra smarts, then they do tend to do these preemptive checks for expiration and stuff like that, because the failure case is more expensive than the check in those. It's a trade-off. But in the vast majority of cases, it doesn't make sense.
Yeah, and I think one of the quirks of Oauth too is that when you're making that API request, there is no standard response because we actually don't document that behavior at all. So doing that pre-check is useful because you can actually follow the standards.
Mm-hmm. Oh, well, I mean, you get back something in the HTTP 400s that might mean your token isn't good.
Right, but we don't have a documented response for that. So
right.
Then you have to implement that on a per provider basis too.
Yes.
Yeah.
Yeah. Thank
Okay,
you.
I think we're out of time, are we?
No, you have a few more minutes if you wanna wrap up.
Okay, great. Well, yeah, thanks everyone. I think that gives us a pretty good list of topics to work on before the next meeting. And just a reminder, if you are interested, looking for people to test out and interop with, please get in touch.
Thanks, William.
Thank you.
Okay. Dick, you're next here. You drive.
I'm gonna drive.
Yeah.
This one goes forward.
Yep.
That one goes back.
Yeah. You want a spec for that?
Yeah. See the manual.
Yeah.
Hi, I'm Dick Hart. I'm going to talk about the reciprocal Oauth, which is now a working group document. How many people were in Singapore? Saw the presentation? A few of you. So for those of you that were there, here's an update on what happened. Changed the name from mutual Oauth, because Brian didn't like mutual, and to reciprocal, which I think actually fits better. Added a reciprocal parameter that could happen in the first flow, so that the party B could indicate what scopes they would like in the push. And of course, it's been adopted as a working group document. So the problem, there's essentially, you want a symmetric relationship between the two different parties. Each of them is calling each other, potentially. And potentially the user could be starting at either of those parties. And so we have this today with Alexa and Sonos, and then there's a number of other ones which I've forgotten which ones have shipped and which ones haven't, so I can't really mention anybody else. But it's deployed now between us and between Alexa and Sonos. And so the previous flow, for anyone that had tried to install Sonos on Alexa, was super complicated. You need to log in like numerous times to go through to do it, because you weren't at the right site, and so you have to get bounced over to one site to go and start something, and all over the place. So I go through that a bit here in the flows. You know, the user is over in the Alexa app, clicks Sonos, authenticates to Sonos, authorizes Alexa at Sonos, user gets redirected to Alexa with the Sonos authorization code. Alexa exchanges that code for an access token, which is your standard flow. And then Alexa has to send you back over to Sonos to start the second flow, and then Sonos sends you back over, which then of course drives the login with Amazon, because we started in the app, but now we're in the web browser. So now the user has to log into Amazon even though they were already logged into the Alexa app. And then they authorize Sonos and Amazon, and the user is redirected back to Sonos with Alexa authorization code. Sonos exchanges that code for it, and then the user is redirected back over to Alexa at completion, which I think the first version wasn't even this clean. It was even uglier than this. So the reciprocal OAuth flow, I made the font a little smaller so it all fit on one screen. A little bit of a cheat there. So 1 through 5 is all the same. Step 6, 7, and 8 are removed. And so what the user is now back over at the Alexa app at the end. A new step is the user authorizes what Alexa is going to grant Sonos, and then Alexa just back channel calls Sonos token endpoint with their authorization code, and provides a context for Sonos by passing Sonos their access token. And then standard flow in step 11, which is Sonos exchanges the authorization code for an access token. So there's a scope now, and so when Sonos comes over, they can include a scope as another part of the flow, as to what kind of scope they would like. And so Torsten asked a good question: how does party A know whether they should go and send a scope over? It's either pre-configured, or obviously in this example, party B sent a signal as to which scopes they wanted. And then the reciprocal authorization code, so it's a new grant type. Thank you. I think, Brian, you gave me the suggestion that we should you have this kind of grant type. And then the party B access token, and per Torsten's comments, all this is really for the party B to understand the context. And then, of course, the authorization code from party A. So that's an example of what that looks like. Something that we're starting to do now, and I'm thinking of adding this into the spec, is, and it sort of follows on. Fortunately, it was nice of Dennis to have his talk right before this talk, because this essentially is additional incremental authorization. And so in the Alexa worlds, the skill could ask for something, and so similarly, where you want it to incremental, the skill may only have been given a little bit of permission at first when the account linking happened and when the user's in the application land, but later on, when the user's asking the skill to do something and the skill doesn't have permission, say to get the user's location or get their email address, is you could have a voice interface where, Alexa asks the user if it's okay for a particular skill to get a new permission. The user says yes. And so then we'd like to go and update that to the skill. And so using this same interface, we can go and push a new authorization code to the other party for them to acquire new refresh and access tokens that now represent the updated scope. And so I just want to call out that we envision this really being a symmetrical relationship. I haven't really come an example where it's asymmetrical, where really the user can start at either side and either party could update the other's authorization. Implementations, as I mentioned. And so I got some typos that people have pointed out in the spec. But sort of opening up for discussion, people have, anyone else think this would be useful besides the other voice assistants? Other questions? Any comments?
Nice.
Anybody have feedback on sort of that updating authorization flow? Who is it?
William.
Hi. Yeah, you said excluding other people with voice assistants, but as we have one, yes, I think this is extremely relevant, and I've seen a very similar set of steps that you presented. So I think it's good to do. Okay.
Any other feedback on it? Anything you think we didn't capture?
Nothing yet, but let me take an action to give it a full review.
Okay. Any thoughts on including sort of another section that you could use the same flow for updating an authorization that sort of picks up on your incremental, but puts it in what would be in a voice assistant world?
So with that example, was that Alexa asking if the user was happy to grant more Sonos scope? Is that?
Yes.
Right. Okay. That's extremely interesting. So that's in a very trusted relationship, I guess, but it makes sense. You don't want the user to have to pull out their phone and review a web request, I guess.
Yeah, well, just like you guys, we have speaker recognition. Yes.
Right. No, I think it makes sense to do that.
Okay.
Thanks.
Yeah, there you go.
Oh, really?
Yes, really. We're doing this.
You asked for it, no?
Yeah.
Annabelle Backman, Amazon. So the current draft has the reciprocal grant request coming back over as part of the authorization response, correct? With the authorization code in the state?
No.
I believe that's what it says.
No. There's an additional scope request. Was that what you're saying? Not the grant.
No, not the grant. I'm talking about the mechanism by which Sonos would tell Alexa, in your example, what scopes it would like to get.
Yes, that's in the authorization code from Sonos.
Right.
And it's the initial authorization response. Yes.
Right. Okay. So what are the trade-offs around having that as part of the authorization response versus as part of the access token response?
I always have to wrap my mind around who's calling who in each of these things.
So if
So,
you look at the screen,
let's see, authorize Sonos.
It's a test whether you really wrote the document.
When I was writing my slides, I got confused as to who was calling who all the time.
So if I understand the draft correctly, in step 4 is the user has granted consent at Sonos and has come back to Alexa with an authorization code.
Yes.
That in that step, Alexa could possibly have received a scope value from Sonos.
Right.
This is what Sonos wants. So my question is so that's kind of coming over like the less secure channel.
Right. And so you're thinking that we could have that in 5, that when
Right.
Alexa calls Sonos with the authorization code, Sonos, in addition to providing an access token and a refresh token, could provide the scopes that it would like.
Right.
Okay.
That would get that over the more secure channel. The flip side, the counterpoint to that though, is that necessitates that 4, 5, and onward is kind of happening synchronously, and that may or may not be the case depending on the backend implementation.
Yeah. Okay. Let's discuss on the list. Yep. I like having a more secure channel, and I think functionally it's in the same place. And adding more stuff in the redirect is always problematic since it's much more limited in its ability. And of course it's open.
Yeah. Especially too, if we consider other people on the list have been talking about recently scope data and having some additional content along with rather than just a static scope value. So you could imagine that getting bigger and being a problem.
Right.
Does that mean you don't need the Alexa authorization code in this case, right?
No.
No,
I don't have in the slide here in step 4. We're also in the Sonos is including which scopes it would like, and the redirect it does back to Alexa. So if you go to, I don't even know what's, I got this clicker. Here. That is where I was putting the Sonos was signaling which scopes
So
it
it was
wanted.
missing in the other slide.
In here, yes, it's not listed there, correct. Yeah. And so what Annabelle was suggested is that it would actually be in this, no, not that call.
In the call you
standard
don't have
call
here.
that happens in 5 to go and add the reciprocal parameter coming back from Sonos as part of its response saying, okay, I just gave you this, and here's the scopes I'd like you to send me. Right. Yeah.
Yeah. I wonder, would you actually, that may be a good idea to include that parameter, because at that stage you could actually then fall back to the other mode rather than failing later on when you have the authorization server not knowing about the functionality of this extension. Or did you consider that case? What happens if you go through and then it doesn't support that? Would it completely fail, or could it fall back to the longer flow instead? Do you know what I'm talking about?
No.
Okay.
No.
So you
Because
define
in order for this to work, both parties have to support it, right?
yeah, but you don't know upfront.
You do
It's
know
not
upfront.
only
I think you'd
both
have to-
parties, but
I think
it's
you'd
also
have
it's all 3 parties: the authorization server, Alexa.
Well, there's really Alexa and its resources and Sonos and their resources, right? But it's really the 2 authorization servers.
Yeah. So you just assume that they know about each other's support for this functionality, and that's it.
If they don't know about it, then they wouldn't be able to do it, right?
But it would fail at some point in time.
Yeah. Well, say
or would it just
say
fail?
Sonos say we thought that Sonos supported it, but they actually didn't deploy it, right? When we would make a call, that call to push the code would fail, right?
Would it then fall back to the longer flow that you showed previously, or would it just fail altogether?
Yeah, they would just fail. Yeah. Because the other flow was essentially a bunch of super complicated UX that both people needed to do, right? So that the longer flow isn't standard at all, right? The initial flow is standard. The longer flow is like a wacky way of trying to accomplish it.
Okay.
Yeah.
Got it.
And to add to that, if you think about how this would fail, if Sonos doesn't support it, then they're just not going to ever send any tokens back or any reciprocal scope back to us. And if we try to give them something anyway, their token endpoint is just going to reject it. If Sonos supports it, but Alexa doesn't, then Alexa is just going to ignore any reciprocal thing that gets sent back. Sonos is never going to get a call to their token endpoint to give them tokens. At that point, if you wanted to fall back, it would have to be Sonos triggering the fallback. But how would you even detect that, right? Like at what point do you decide it hasn't been called? And then how would Sonos inject something into the experience? It's not really.
I think the disconnect
possible.
was assuming that the current flow was actually a standard flow, which it isn't. Step 6 here is a non-standard,
Okay.
right? Step 6, usually you're all done by 5 in the current.
I hear some voices. Is it just me?
Somebody's on the phone. His mom called him. Okay.
Relaying another comment from Torsten from Jabber, the flow description given on slide 6 would be a helpful addition to the draft, since even you seem to get confused about it. Or about who's calling who.
Right. Thank you for pointing out the obvious, Torsten. Okay.
And what's
Yes.
10B? Why is it 10B?
What's that? Because it isn't really 10. It's a slightly different.
Okay.
It's a different, that's the new step is 10B.
I see.
But it has an equivalent of what 10 was in the other
I see.
one. Thank you, Torsten. How was your day today? Okay. Other questions, feedback?
Any other comments?
So I'll do a new draft with pictures.
Yeah,
Yeah.
figures.
Yeah.
Okay, good.
Okay, thank you.
Thank you, Dick. Thanks. Okay. Next. Brian. Drive.
Close enough. Okay. I'm going to jam 3 different documents into one update here. A lot of it's just sort of some status updates and overview, but a couple of these mutual TLS and token binding maybe have some relevance to the POP token stuff that's going to be discussed on Thursday. And so, yeah, welcome to not San Francisco.
You didn't have the appropriate pictures, so you
I don't know.
just took some other
I've
ones.
never been to Montreal before, so
Oh, is it?
reminder, this meeting was supposed to be in San Francisco.
True. True.
Until
Okay.
our illustrious president. I won't go into the politics. All right, so I'm going to start with Oauth 2 token binding, which first sort of got introduced to the working group in Berlin at IETF 96, hence my gratuitous photograph here in Berlin. So I've talked to a few people about this token binding in general, and there's the Oauth application of it, and then there's the lower layer technologies that make token binding work. And I want to give a brief overview of kind of how that stuff works, which will maybe help inform how the OAuth pieces work and enhance understanding of people reading that document. I noticed one of the authors of that stuff is in here, so I'm sure he will make sure I'm right on point. But there are 3 core drafts that make up that set of documents right now coming out of the token binding working group. The last meeting this week on Friday, the very, very last meeting is for that working group, if anybody's interested. It defines basically 3 things: how the use of token binding is negotiated in the TLS handshake, the protocol of token binding, which is really just the message format, and then the application of token binding to HTTPS. What token binding does is enables this long-lived binding of cookies or other security tokens like OAuth tokens to a client-generated public-private key pair on the browser or client or underlying platform. The use of this is negotiated in a TLS handshake via TLS extension. Possession of the actual token binding key is proven by signing the TLS exported key material and then sending that along with the public key and a few other things as an encoded HTTP header on every request. And then in turn, the server can bind cookies or other tokens to that key. At least in the browser use case, the key is scoped to the effective top-level domain +1. The scoping around OAuth is a bit ambiguous, and intentionally, but generally that's the scope, at least in web browser cases. And then in federated sort of cross-domain cases where you want to bind to a key that's used in a different domain, there's this thing called a referred token binding versus what's normally called the provided token binding, where the provided is between the client and the sort of the main server. The referred enables the client to communicate a key that would use with a different server so that that original server can bind tokens to that for its usage. A little bit more graphical showing of how this works in the TLS handshake. There's just a hello extension, number 24 if you're interested, that the client includes in its client hello, along with basically what signature algorithms it supports to do token binding. There's 3 defined right now. And then if the server is happy with this and wants to do token binding with this client, it responds, including the extension in its server hello, same extension, same structure, but it only has one of these key parameter types, which is the key signature type, basically indicating to the client, hey, this is the one that we're going to use. In this case, in this example, the client offers up a couple different choices and the server responds with, okay, let's do token binding and please use ECDSA with the P256 curve with me. Assuming negotiations are successful in the TLS handshake, then on every subsequent HTTP request, the client includes this header, which is the sec-token-binding header with an encoded token binding message. In that message, there can be one or more token bindings. Each individual token binding indicates the type, which was either the provided or referred I talked about earlier. So it's either saying this is the one I use with you normally, or this is one that I use with another server. The token binding ID, which is basically a name for the key, the public key, with a type indicator as well, but it's effectively the public key. And then a signature over that type, the key type, and the exported key material, which is defined in an RFC. I can't remember the number, but you can think of it as basically like a cryptographically secure identifier contextualized for this usage for the individual TLS session. And then there's some room for extensions. What this does is, when verified properly, this proves that the client possesses the private key with respect to that TLS connection corresponding to the public key that was sent in that message. And these keys are long-lived and span TLS connections. So while a TLS connection might be torn down, expired, or whatever, the actual binding to this key can persist beyond that because the signature is over the EKM for the TLS session, but the key itself is longer lived. So if a new session is brought up, the client just needs to use the same key and sign the EKM from that session. Connection. This idea of cross-domain or federated token binding is also supported in the web browser use case. There's an HTTP response header that the relying party or client in the OAuth OpenID world includes on its redirect over to the IDP or the authorization server. And what this does is, it's just called include referred token binding ID is true. What it does is it signals to the client that, or the browser, that it should reveal on the subsequent request, the IDP, both the normal token binding it would use as well as the token binding that it would use between itself and the relying party. And this allows for that identity provider to bind tokens to the key that the browser uses with the relying party, basically binding for when it comes back for that initial connection there. And that's the provided and referred is the name and the distinction between the two. Again, provided is the one that's used normally with the server you're talking to, and referred is from a referred site. In this case, it's the same header, and just inside of that encoded message, it actually includes 2 token bindings instead of 1. And there's guidance in the document itself that basically suggests that generic token binding implementations should be able to send referred based on some other signal to the API itself or from the application. And ultimately, that's what a lot of OAuth is going to rely on is the hopes that implementations do, in fact, expose that in a reasonably usable way. So with that in mind, I know it's quick, but hopefully gives a little bit of overview. The OAuth 2 token binding standard that's being worked on within this working group basically provides an OAuth 2 proof of possession mechanism based on token binding that defeats replay or play of lost or stolen security tokens of all sorts. Probably the most interesting and the most applicable use case is binding access tokens. You bind those against the referred token binding ID, similar, sort of supporting that the federated use case. So the client makes a request, includes both the normal token binding ID that it would use with the AS, as well as the token binding ID or key that it would use with the resource server. The authorization server then binds the access tokens to that key that we would normally use with the resource server, and thus provides this proof of possession mechanism around the access token, binding it to the key used with the resource server. And this can be represented in a JWT access token, as well as the introspection response with the CNF, the confirmation claim, defined, I think, in RFC 7800. And inside of that, a new confirmation value, TBH, for token binding hash member. So it's a SHA-256 hash of the token binding ID included inside either the introspection response or the JWT that basically is a hash of the token binding ID, which is what allows the resource server to make that comparison and check whether, in fact, the issued token is bound to the key, which is in turn proven possession of by the client. There's also some text in there about binding refresh tokens just to the provided token binding ID. There's some support for binding authorization codes to variant flows around native app clients and web server clients. They're a little esoteric. I won't go into the details. And then speaking of esoteric, there's also some language about binding JWT-based authorization grants and JWT client authentication. That's it in a nutshell. I won't go into any deeper details, but I will cover a few happenings since London. Draft 7 was published, and really the only main difference here is that it was clarified that the encoding of that TBH value is base64 URL encoded, but that's somewhat ambiguous in some cases, so it was clarified that that does not include any of the trailing pad characters or white space or anything else. This actually was a result of a review on the MTLS stuff from Justin that was equally applicable here, so I just added the clarification. And I updated and fixed a few references that were either referencing wrong parts in other documents or sort of the HTML tooling where it does self-references when it shouldn't and links to those, as well as updating them. Related, not directly, but somewhat related, the OpenID Connect token-bound authentication draft, a new draft of that was published. And it's worth mentioning here, just because the TBH confirmation claim is actually defined in there. So the same clarification was added in both places, even though the sort of the normative definition of it is in that draft. The three underlying sort of core token binding specifications are, I've said it now, I think 2 or 3 or maybe 4 IETFs in a row that they're almost done. But in this case, they really are almost done. The token binding over HTTP is in the RFC editor's queue, which is really good. And then not far behind it, the TLS extension for negotiation and the token binding protocol itself are in this approved announcement to be sent. So they're just waiting for AD follow-up there. And I think they're close-ish. So it shouldn't be much longer. And that's where we're at with token binding for OAuth. Next up on the, sorry.
Carmida DNA. I'm thinking about 2 apps reside on the same device, whether they can share a TLS connection. And my understanding is no, because the TLS token binding negotiation is at the TLS level. So if one app already has a TLS connection to the same authorization server or resource server, then another app should initiate another TLS connection so that it can have a different configuration for the token binding, whether the application B wants to use the token binding or not.
John Bradley, Yubico, and one of the chairs of the token binding work group. So the definitive answer is it depends. Alexi, who's eyeballing me, would probably have the better answer for Windows, which probably has the most advanced implementation. But it's going to, if you've implemented token binding by including Cronet into your application and every application has its own key store, then yes, they're all going to be different. If you're running, say, on Windows that actually provides an API, there may be a way to actually share the same TLS connection and token binding via some magic flags that Alexei is now going to illuminate us about.
It's Andre, but yes. Andre Popov, Microsoft. So each application will have its own TLS connection, I'm assuming. But the token binding keys can be shared, and that's platform specific, right? So like the extent to which token binding keys can be used by multiple applications is platform specifics. On Windows, we have a concept of app containers, and if the applications are in the same app container, the same integrity level, then they can share token binding keys.
Karl Maida again. And the first motivation of the PXE is to distinguish two applications and deciding the same device to not confuse each other. So, say how the context of the token binding ID with regard to the sharing of the TLS. So there should be an API between the application and the operating system, so that I am who and my token binding key is something. Especially on the first authorization case and later token bound token to the resource server.
Right. So again, that's application specific. So that's probably the part of the HTTP spec that it took us the most amount of time to negotiate with the IESG, is trying to explain that different vendors are going to have different APIs and slightly different takes on it. So on Windows, apparently that you have some concept of an application group, so they can only share if they're part of the same, i.e. signed by the same developer key or some such thing. Perhaps Android will have a similar mechanism, but since they haven't said how they're going to expose it on Android, we can't answer those questions until the various operating systems actually implement the APIs. But there should not, token binding IDs or token binding keys ought not to be shared between completely unrelated applications. In a single browser, yes, it's a single pool, but again, even in a single browser, it may not be the same pool because some people are creating separate token binding keys for private browsing mode, etc. So again, So we'll have to see how that plays out as the developers actually implement it for native apps.
Karl Maida, okay, I think I understand the whole, picture right now, but it could be convenient whether, description of this discussion in the draft or in the document or somewhere like an implementation note or something. That would be greatly helpful.
Annabelle Backman, Amazon. So regarding token binding of access tokens received from the token endpoint, it wasn't clear to me, is there a limit? Is it only one referred token binding that you can include, or could you request an access token that is bound to n different referred token bindings, referred token IDs, whatever the right term is?
The terms are a little hard. Only one.
Okay, so
which is a limitation, an intentional limitation, both of the way that the token binding message is structured, and only, at least at the HTTP layer, only allows a single referred, as well as the confirmation method claim that we have only allows for basically one confirmation type of each. Your question sort of maybe begs at the scoping of the keys, and that's why I mentioned earlier that OAuth is a little bit, how it applies to OAuth is a little bit loose. In a browser-based world, they're scoped to the effective top-level domain +1, so that they're not more broadly scoped than cookies and privacy considerations and all that. An OAuth client, given the right APIs, could quite conceivably use the same token binding key across a wide variety of resource servers.
If they have a trivial deployment of their system.
It's the client that's largely managing them. So they have a single key that they use with
Right,
some
and
number
if you're talking about a widely distributed system where it's completely different services in your backend that are using tokens for one scope versus another, trying to get all of those pieces to share the same token binding ID, particularly when you consider that token binding ID is actually getting bound like up at the VIP or the load balancer somewhere away from the actual systems that are trying to do stuff with it, that actually know they need to share. There's some, I don't really think it's feasible to just assume that that's going to be able to be shared. So I think we should think about how we can get from a refresh token to access tokens bound to n different token binding IDs.
One of the reasons to binding it to a key is so that you have to have that key in order to use it. And I recognize that widespread access and distributed systems to private keys can be problematic, but I don't think we're in a position where we want to undermine the value of the protocol to support that kind of case.
Let me rephrase my suggestion. It doesn't necessarily have to be a single access token bound to multiple referred token binding IDs.
Okay.
As long as there's a mechanism for a service or for the client to get an access token that is bound for a token binding ID from some other service separate from the one it requested previously. This probably just falls in the realm of best practices or non-normative text, but yeah.
I think maybe it is some non-normative text because I think, if I'm understanding correctly, that the draft would support that right now. You can present a refresh token with the referred token binding ID for this service, use that, and then at some time later present the same refresh token with a different referred token binding ID and get a new access token bound to a key suitable for use with this service.
But there are some implications of that, as far as those tokens have to continue to both be valid. The subsequent refresh for a new token shouldn't invalidate the previous one. So there's implementation details that fall out of that again aren't normative, but are probably worth being discussed as best practices or non-normative text.
So we have identified that in some clustered environments where the client is being distributed across the cluster, it may just be that token binding isn't the right answer, that mutual TLS may actually fit better for some of those server-based applications. The sweet spot for token binding tends to be more the mobile applications, which are dynamic and generally not clustered clients.
That is true, although there's wording and support in here specifically for allowing a client to have an unbound refresh token. So it can be used from different nodes or whatever, while still obtaining bound access tokens for outbound use specific to a key that only they have.
I'm actually a lot less worried about the refresh token being bound to a single token binding ID, just because that's having a central system or at least a single distributed system that is doing token refreshes. That's kind of a reasonable thing. It's the access token that's potentially being used by n different client systems to m different resource servers where I see the problem. But I think that's a good point that this doesn't have to, or token binding isn't necessarily the hammer to use on every nail.
That's absolutely true. Yeah.
So as far as the resource server is concerned, you're either using a JOT or some sort of introspection. So in principle, the token binding ID for that particular access token can be contained inside of the access token. So you're not really, just because you're creating a new access token, potentially for a different part of the client that's talking to that resource server, both of them can be valid at the same time. You're not revoking it. So I think that there may be some of these larger sort of edge cases that we might want to go through if we have some extra time here. But again, for the larger server implementations, it just may be easier to use mutual TLS, which still works.
So we cut the line after Dick.
Perfectly.
So, Dick, you have a comment?
Yes.
Go ahead.
Dick Hart, Amazon. Yeah, I haven't looked at the spec in a while, so I don't know if this is included, but just picking up on what they're talking about, one of the issues in the past is that your TLS layer is managed at your load balancer, but your access token is at the application, right? And so how do you get the trust where the ID is negotiated somewhere different than where the app's trying to verify? It sounds like not necessarily, that maybe some standardization around how does a load balancer, what header does it pass that down to the app? Does that?
That's a
Okay.
fantastic idea, Dick.
Okay.
And so I'm working on exactly that, if I understand you correctly, and it's going to be discussed on Friday, last thing on Friday. If you're still around, please come to the token mining working group session and express your support for such a draft.
Okay. Good.
Thank you.
Nice.
It's in the token mining working group. It has a horrible name. I can't do better. It's HTTPS token binding with TLS terminating reverse proxies or something like that. But you can,
short header name.
it's really short, but you can find the draft in the token mining working group. So, but yes, I agree it's a problem, and I'm trying to put out something that'll help solve it.
So Brian, you want to give a quick update on those documents?
Can I do it quick?
Yeah, it's 5 minutes.
5 minutes? No problem. All right. Oauth Mutual TLS. Some of this is give a real quick overview and context. Why is this being worked on? It's an enhanced security profile of Oauth 2 based on TLS client certificates, mutual TLS. The draft is already being used by open banking, PSD2-esque sort of regulatory regimes, as well as being referenced and profiled by other SDOs. What is it? It's an asymmetric key-based client authentication method for the client to the authorization server using mutual TLS. There's two methods, PKI-based and a self-signed certificate mode, and then also mutual TLS certificate-bound access tokens for proof of possession, protected resource access. So actual POP tokens. And this, similar to token mining, but with a different name, uses a confirmation member inside the confirmation claim. This one's called X5T pound SHA-256, and it's just the SHA-256 thumbprint of the certificate embedded inside the access token confirmation claim. A few things have happened since London. Working group last call happened. I was on vacation for some of it, so that was fun, getting the feedback while I was trying to relax on the beach. Draft 7, 8, and 9 have been published. Mostly it's been editorial clarifications and improvements from people making my text better. Thank you all. One sort of important thing I think is worth noting here is that I dropped the use of the sender-constrained terminology with respect to access tokens, because a reviewer pointed out that going back to the POP architecture document, sender constrained is defined as a client literally authenticating itself via some other method and having an access token constrained or bound to that client. Whereas this one actually is kind of a weird middle case, but more than anything, the access token is bound to the certificate itself and not the client identity. So trying to be more consistent with terminology here, I just got rid of the sender constrained terminology. And I include a picture of Nat here presenting at a conference just a couple weeks ago, extolling the virtues of sender constrained tokens and this particular draft. I guess he's not here, but I was hoping to give him a hard time about using the wrong terminology and push on it. But that's the only major difference that's not editorial. And that in turn came along with a changing of a metadata parameter name to reflect that small but legitimate breaking change. And that's all the stuff that's really happened. And I wanted to make the Pulp Fiction reference in here, trying to find the shepherd for this document. But this has all been taken care of this morning. We got a shepherd, started the shepherd write-up, so Document state has been changed. So this is now, this was legitimate on Monday, but is no longer accurate. So thanks for doing that.
Time flies.
Time flies. Things happen quickly here in the IETF.
But don't say that if you work years on token binding, right?
I was joking. It was, I was being ironical. On Monday. Yeah, not bad, not bad. All right,
we get the slides much earlier, but
so that's MTLS. Things are moving. Thanks for all the reviews and commentary on it. I'm happy with where it's going. I'm looking forward to it progressing.
Thank you.
Oauth 2 token exchange now in draft 14. Real quick overview. This is like a STS framework via the token endpoint on the authorization server, STS being security token service. I want to try to provide context here, but it's hard because it's really sort of a Swiss Army knife of just token in, token out, actually 2 tokens in some cases, and a token out with claims or content representing that delegation. This is just one use case, which is sort of the resource server as a client gets an access token in from a normal OAuth flow and exchanges that with its own authorization server, some other authorization server, its own authorization server only, to get a token that's appropriate for usage on some backend system. The details are here. It's just, but it's one of many use cases that are facilitated by this. One that I just hear a lot. That's enough for context and an opportunity to show a picture of my kid from a year ago. Happening since IETF 99. So 99 in Prague was actually the last time I presented on this because it's been sort of in the throes of review or ladder, not working group, but ladder review. We've had drafts 10, 11, 12, 13, and 14 published. Clarified some stuff around the ACT claim. The ACT claim is the actor, sort of a claim about to whom this token and its privileges have been delegated. And it says that, it just clarifies that only the top level claims about the subject and the token itself, as well as the current actor, which is the most recent actor in the ACT claim, are actually to be considered when applying access control decisions. Had several clarifications and editorial improvements, stuff mostly out of AD review. I did change with working group consent scope and client ID claim names to what they are now. They had previously been SCP and CID to align more consistently with what's in the introspection draft and try to just normalize names. I tried originally to go with the shorthand convention there, which made sense at the time, but in retrospect and having some developers and other spec writers look at it, consistency between the two made a lot more sense and will make even more sense probably when Torsten presents his next draft here about signed introspection responses, because then they'll line up. Some new URIs were added a long time ago to represent SAML tokens. No normative stuff around it, just giving URIs to say, hey, this is a SAML token. And I have answered quite a few questions, and with this fact that there's no normative support in the document for validating or issuing access tokens from other authorization servers. It's always been that way, but it seems to be something that some people are interested in asking about, but I think that the complications as well as the security considerations definitely warrant keeping that out of scope for this document and having those kind of use cases be supported by a more explicit exchange such as the JWT bearer grant or JWT assertion grant. Currently, this document is in AD evaluation, waiting for a write-up on a point raised that I think I've addressed with that ACT claim. I think Ecker left, so it's sort of, that kills a lot of this slide. But I had 3 things I wanted to do in this slide. One is I always include pictures of the places where we've been or gone. Closest thing I had here was a picture of me in Bangkok from almost 20 years ago. I did want you to get the One Night in Bangkok song stuck in your head, so hopefully you'll have that going on the rest of the night. And the main point of the slide was to try and sort of goat Ecker into actually closing out his point needed and moving things forward, because I think it's been taken care of and we're just sort of sitting here. But he left earlier, so.
Yeah, so, yeah.
So One Night in Bangkok.
We'll talk to Ecker about this.
And with that, I'm done.
Okay, thank you. Give Torsten 5 minutes.
You can do it. Sorry, Torsten.
Torsten, can you hear us? Is he still there? Torsten? Is he responding? No. Okay. So maybe the problem is Thursdays we can't present that. Yeah. Okay. Torsten, can you hear us? Oh, there you go.
Hey guys, can you hear me?
Yeah, we can now. You have 5 minutes.
This is such a complicated tool. How much time do I have?
Okay, go ahead.
Yeah, then is the presentation visible?
Yes.
Okay, because I can't see it. My name is Thorsten Lodderstedt, yes.com, and I would like to present a individual draft that I did with Vladimir Truvianov from Connected ID. It's a small extension to token introspection. Next slide, please. Which allows a resource server to request and an authorization server to respond with a JOT. Rifat, can you please? Oh, I can't see which slide you're showing. So assumption is slide number 2. So it shows the extension. So the client asks for a JOT representation of the introspection response, and the AS just answers with a JOT representation, which allows the AS to sign and potentially also encrypt the response. Next slide, please. The use case for that is quite simple. We are looking into high assurance level use cases, such as payments and electronic signatures. And those use cases require the resource server to keep track of all the data that it consumes from authorization servers for auditing and non-repudiation purposes. And that's why it's a good idea to have a signed assertion on the resource server side. And the use of structured access token is not always possible. For example, in situations where you want to have an integrated authorization, which allows the client to obtain a grant that is good for interacting with different APIs, for example, to sign a contract on one hand and to initiate a payment on the other side. So we can't carry all data in one JOT because it would violate the privacy regulation. And that's why we think a token introspection is a much better fit, but token introspection needs to support signing and potentially encryption, and that's why we have written this draft. Next slide, please. So this shows in detail how this is going to work. It's quite simple, and there is a new accept, or the client, the resource server uses the accept header application /.jwt. Next slide, please. The AS just answers with the respective GWT. Next slide, please. And the AS determines whether what algorithms are being used and whether there is just a signed JOT or a signed and encrypted JOT. Either by default or the AS may supply some configuration data via using dynamic client registration. The draft also defines some registration values for that, following the pattern established by the OpenID Connect dynamic client registration. Next slide, please. So that's the last slide. I already presented the draft in London and got some pushback on the topic because we also had included the proxy use case. Because of the feedback, we got rid of that on focusing on the non-repudiation between RS and AS entirely. So what we did is we incorporated, we did a version 01, and we incorporated feedback from the mailing list. So thanks to Niels and Petri for giving us feedback. We added a lot of stuff regarding security considerations. We added metadata and so on and so on and so on. And the reason why I would want to present that today is I would like to ask the working group to adopt that as a working group item. That's it from my side.
Now I will cut the line after Justin.
should have said before.
Can someone
yeah.
come over to the line so I can see the line?
Right. So Justin Richer, they deleted all the stuff that I thought was a terrible idea from the last document. So that's a huge improvement. The security discussions is going in the right direction. I think it needs a lot more chewing on, but that's what we do here. I would support this going forward with the caveat, and I raised this in London as well, that we think about using this response mechanism for other parts of the OAuth protocol that might also want to sign response, token endpoints, registration endpoints, yada, yada, yada. We've got a bunch of other places where this patch might also apply. Whether we do all that in one document or not, I don't know or care right now, but I suggest this as a good starting point moving forward and support it.
Thanks, Justin. So we're gonna try to take a hum on the mailing list or ask for adoption on the mailing list because we don't have time right now. Okay. Thank you very much, everybody. Thanks. We're
Thank you,
done.
Torsten.
Thanks, Torsten.
Thank you. Have a pleasant meeting.
Yeah.